let's get started in section 2.7. The topic is graphing techniques. Mostly what we want to focus on is transformations. There are three basic types of transformations that we'll talk about. We'll talk about a translation, also known as a shift. We'll talk about stretches and compressions, and then we'll talk about reflections as well. And so what we're trying to do is graph more different types of functions. And so we already know how to graph 6 basic functions. That was the topic in the last section. And so now when we see a new function, for example, something like y equals negative 3x squared plus 4, we're going to learn how to recognize a function like this as just a series of transformations on the basic function. And so we'll be able to sketch the graph of this function by knowing the graph of the basic function and then the transformations that are applied to it. So this problem right here, graphing this function, is a little bit complicated, but we'll get to something like that at the end of this section. In the meantime, what we want to do is we want to start with translations. And so you can see the question here, what happens to the basic function y equals absolute value of x if we add 3 outside the absolute value? And so that's the function y equals the absolute value of x plus 3. How does it compare with the graph of the basic function, y equals absolute value of x? And so what we're going to do is we're going to complete a table and a graph in order to get an answer, and then we'll describe that answer in words. We'll describe the transformation in words. And so let's get right to it. I tried to skip a little bit of time by going ahead and filling in the table and the graph for the basic function. Remember, we already did this in the previous section. And so now let's just go ahead and work on the table and the graph for the new function, absolute value of x plus 3. So if you plug in a negative 4, then you get absolute value of negative 4 is positive 4 plus 3 makes 7. And similarly, you'll get 5, 3, 5, and 7 for the rest of the y values. And so then we can just plot those points at negative 4, 7, and negative 2, 5, and 0, 3, and positive 2, positive 5, and positive 4, positive 7. And then we can draw a nice straight line to make the graph 2 straight lines, the V shape. There's a line on the left and a line on the right that meet together at that corner there at 0, 3. Okay. And so when we compare the new graph to the old graph, what happened? Well, it just shifted up 3 units. So when we describe the transformation in words, we want to say shift up 3. The next question I want to ask is, what would happen if instead of adding 3 outside the absolute value, what if we added 3 inside the absolute value? And so once again, I've got the basic function y equals absolute value of x. The table and the graph are already completed. And now I have the new function, absolute value of x plus 3. And so notice I had to change the inputs this time in order to get the graph that I wanted. You'll understand why in just a minute. So let's go ahead and plug in negative 7. And when you do that, negative 7 plus 3 is negative 4, and then the absolute value of that is a positive 4. And so similarly, we'll get 2, 0, 2, and 4 for the rest of the outputs. And then we can plot those points at -7, 4, -5, 2, -3, 0, -1, 2, and 1, 4. And so then we can draw the graph. And so what happened this time? So once again, the graph shifted, but this time it didn't shift up or down, it shifted left, right. And in particular, it shifted to the left. So shift left 3. Okay. So here are a couple more questions. Now let's see if we have the idea. So what do you suppose the transformation looks like for y equals absolute value of x and then a -3 outside? Well, if absolute value of x and then +3 outside, if that shifts the graph up 3 units, then you would expect that this new function -3 would shift the graph down 3 units. And what if we have x -3 all inside absolute value? What does that transformation look like? Well, since it's inside the absolute value, then it should do something similar to the +3 that was inside the absolute value in our example up above and our graph up above. +3 shifted to the left, so -3 we should expect that to shift to the right. So let's back up for just a moment and make sure we emphasize that this -3 is outside the basic function, and so that will shift in the vertical direction. This -3 is inside the basic function, and so that will shift in the horizontal direction. And then just the plus or the minus will determine whether we're shifting up or down in the vertical or left or right in the horizontal. Okay, so once again, so let's try to summarize what we've just talked about here. So if we add or subtract a number to the basic function, then that gives us a translation. So add, subtract gives us a shift or a translation. And then if we add or subtract outside the basic function, then that's going to be a vertical change. And if we add or subtract inside the basic function, then that's going to give us a horizontal change. So let's go through these. If we have f of x plus c, where f of x is the basic function, then that plus c is outside the basic function, and so that will be a vertical change. And then since we're positive, since it's a plus c, that will take us up. That will shift up c units. Minus c outside the basic function will shift down c units. Now the plus c is inside the basic function, and so then that's going to be a horizontal change, and you might expect the plus c to shift to the right because that's the positive x direction. But what we just observed up above is that the direction is switched from our intuition, right? The plus c inside, the plus 3 inside the absolute value didn't shift to the right, it shifted to the left. And so in general, f of x plus c will shift to the left a distance of c units. And then the last one would be to the right. And so now we know just enough to start to do the kind of problems that we want. So in particular, let's look here at example 1. We have a function x plus 2 quantity squared minus 1. What we want to do is we want to use transformations to make a rough sketch of this graph. We don't want to use a table of values. We don't want to plot every point perfectly. We just want the basic shape of the graph. And so what is the basic function in this case? Well, basic functions, there are only 6 of them so far. So when we ask what's the basic function, it's one of these 6 choices here. And so when we look and we see that in our example that we have this square here, then that tells us that our basic function is y equals x squared. So part A, I'm going to abbreviate basic function BF. I'm going to write y equals x squared. And then in part B, I'm going to abbreviate transformations like that. And then there are 2 transformations. We want to work our way from the inside out. We want to ask what's the first thing that happens to the input x. The first thing would be this plus 2. It happens even before the squaring. That plus 2 is inside the basic function. And so this would be a shift left 2. Shift left 2. And then the next thing that happens is the minus 1. That minus 1 is outside the basic function. It's outside the squaring. And so this is going to be a shift down 1. And so now we're ready to make our sketch. We're going to start with axes. We're going to draw a rough sketch of y equals x squared. I believe we made this rough sketch in the last section as well. So now it's really important. We want to label it y equals x squared. And then we want to shift that graph 2 units to the left. So come over to the left and put a little scale here. And now it's really nice to have more than one color pencil or pen so that we can distinguish each of the graphs from each other. So this is the intermediate graph, y equals x plus 2 quantity squared. And then we want to shift down 1 unit. And so then that vertex will come down 1 unit. And then what I'm going to do is I'm just going to draw the same shape again, right? So I have the basic graph in blue, and then I tried to draw that same shape, same size, same shape, just moved over to the left and now moved down. Notice that the red graph should never intersect the green graph, right? Because it's always below the green graph by a distance of 1 unit. It doesn't have to be perfect, but it should not intersect. The red graph and the green graph should not intersect with each other. So this is h of x is equal to x plus 2 quantity squared minus 1. And that's the graph we want. So that's really a nice idea. That's the big idea in in this section. We just need to practice a little bit more. We need to we still need to study stretches and compressions, and then we need to study reflections, and then we need to practice doing problems just like this first example. So we'll go on in the next video.